fifth special type of surface we'll look at in this section is the surface of revolution. And if you looked at your Calc 2 notes, we used to find the volume or the surface area of such a thing, right? We'll attempt now to find the equation of the surface, not just, the equation of the thing that's rotated, but the actual equation of the surface. That's really not that hard. First, think of a generating curve that in the, let's say, in the YZ or in the XZ planes. For this example, say the curve is in the XZ plane, x equals some r of z in the XZ plane, and that's revolved about the z-axis. Okay. Then the cross sections in the plane z equals 0 will be circles of radius r of z sub 0. So the curves each have equation. Remember, the cross sections are always circles. When you chopped some surface of revolution up the right way, you wound up adding up all these nearly cylinders, although they weren't actually cylinders. They're small enough that it didn't matter if they weren't exactly cylinders. So that should be familiar to you, that you'll get circles in one direction. And so then x squared plus y squared would be equal to r of z sub 0 squared in the plane z equals z sub 0. But if we put in z as a variable instead of z sub 0, it'll produce an equation valid for all values of z. So here it would be x squared plus y squared equals r of z squared. This would be in the, what plane was this in? This was in the xz plane. Okay. So here's how you find surfaces, or the equation of the surface of revolution. If the graph of a radius function, a generating function, r, is revolved about an axis, the resulting equation is one of these, okay? Revolved about the x-axis, then y squared plus z squared equals some function r of x squared. How do you determine this function? Well, it depends on what you're revolving about the x-axis, right? Revolved about the y-axis, then x squared plus z squared equals r of y squared. Now, what r of y? Well, that depends on, if we're revolved about the y-axis, I guess that depends on the equation in the two-dimensional. And revolved about the z-axis, then x squared plus y squared equals r of z squared. So let's do one. Find the equation of the surface of revolution if y equals 1 over z is revolved about the z-axis. So about the z-axis, here it is. So x squared plus y squared equals generating curve squared, right? The generating curve, y equals 1 over z. So here's the 1 over z. And x squared plus y squared is just the left-hand side since it's revolved about the z-axis. And this one's in the book, but it's not graphed in the book. And it's actually, there's a good reason. This is very difficult to graph, because if you notice, the denominator of this and this could be 0, in which case it's out of the domain. The origin is not in the domain, so if I try to graph this on any portion of the xy plane that contains the origin, I'm going to get some kind of error message. So I cheat a little bit, and I add a very tiny little number to the radical, so I don't have 0 in the denominator, and then I can actually get a pretty fair picture of it. And here it is. If you were to notice, look at it from the side, y equals 1 over z would be this curve. The z-axis is right here in the middle, see, where x and y are both 0. So we get this unusual looking curve. Y equals 1 over z is actually this. When you revolve it, it becomes this piece. But don't forget, y equals 1 over z also has a part below the y-axis, right, where these are negative numbers. And so if you revolve that, here would be the blue part, the lower part. So that's that particular surface of revolution. Cool.